Well, see, dear friends, this is, let's do some questions, practice what we have developed our concept, how to apply those concepts. See, there is a PV plot given here, and regarding P and V, we have only information regarding P. We don't know what is this V and what is this volume. No idea. Only here at this point pressure is given 3P, and at this point pressure is given P. So similarly here also P, and here also 3P. The only information this is given, no nothing given about the nature of gas, nothing about given about the quantity of gas. So what you can take, this information is given only. So to solve such type of problems, first you have to identify what is the quantity, and if quantity is not given, then you have to take one more, right? So and see, different paths are given: a b c, a to b, b to c, a d c, a to d, d to c, and a to c. This is a direct path to this. So basically here you can say that this is initial state. A is the initial state of our this system, and C is the final state of our system, right? So we have to move from this initial state to this final state via three different paths: A, B, C, A, D, C, and AC, right? And some information is given: QAC, from here to here along this path, what is heat change, that is given. WAC, what is work involved in this step from along this path A to C, it is given. WADC, ADC, this work is given. WADC, this work is given, right? What they have asked? They have asked E of A to C, from here to here, what is the change in internal energy? First option. After that, heat change, ADC, ADC. See, WADC you have, and QADC they have asked. QADC they have asked. Work ABC, along this path, work they have asked, and heat change along this, QABC. So see how to proceed such type of question. So solution: initial quantity is not given, so we can take one mole. So n is equal to 1 mole, and it is constant, and it is what? Constant, right? What about temperature? What about temperature? Is the temperature is constant? So we cannot say whether the temperature is constant or not, we cannot say, right? So forget that. Now first point, first option, we have to calculate delta EAC. So A, apply the concept. What concept you are knowing? Delta E of A to C, A to C is equal to, apply thermodynamics first law, delta Q AC plus delta W AC as per the first law. The first law, right? QAC is known. QAC minus 120, this is known. So put here minus 120 joules, right? minus 120 joule, and WAC 75 joule. So WAC plus 75 joule, right? So delta E A to C is equal to minus 45 joules, right? And this is the answer. Answer. First part, right? Now, what other, points or other generalization we can write from the concept? We know that in change in internal energy is a state function. So this will depends on the initial and final state. It is independent of the path. So we can write here, since delta E is independent of path. So what we can write? Delta E AC is equal to delta E ADC is equal to delta E ABC, or not? Think, we can write this or not? See, this is a state function, so it depends on the here what is the value of PV&T, and it depends on the value of PV&T here. How this value is achieved, that is immaterial. So change in internal energy, whether you are moving along this path, or you are moving along this path, or you are moving along this path, any path, if you reached here, the internal energy is same. So we can write delta E A to C is equal to delta E ABC is equal to delta E ADC as the property of state function, right? Good. Hopefully it is clear to all of you. Okay. Now, first part is okay. Now, second, heat change in ADC. So, B part, heat change delta Q ADC. Delta Q ADC we have to find out, right? Okay, no problem. Delta E ADC, again apply thermodynamics first law. Delta E ADC is equal to delta Q ADC uh, plus what? Delta W ADC. And I think something is given, this delta WADC, work along this path is given. Although all of you are knowing from here to here the work is zero. WAD is zero, constant volume, isochoric process, PV work is zero. So basically this WADC, what here it is written, you can write this WADC is equal to WAD plus WDC, and this is equal to WAD is equal to 0 plus WDC, right? So sometime in the question this also may be given, that WDC is given, so you can use that value for WADC, no problem. So in place of this WA, you have this value minus what? 45 minus 45, this is minus 45 joules. You want to calculate this delta Q ADC plus you have this value, what? 95 joules, right? So 95 joule they have given this, right? So delta Q ADC is equal to minus 45 joules minus 95 joules. So this is equal to minus 140 joules. And this is the answer of the second part. Hopefully all of you are clear in this. Okay, now come to the next. Work done WABC. This time work done, it is asked along this. So this is a little bit tricky. This calculation, see, delta WABC is equal to, we can write delta WAB plus delta WAB, A to B plus B to C, plus delta WBC, right? This is our, basic equation. WBC is 0. Why? Because this is isochoric. And WAB is isobaric. So this is not 0. So this is equal to minus of this minus of P external dV. We can write P external dV. Okay, and P external is 3P and dV, right? Because 3P is given. 3P, here the pressure 3P, here also 3P. So constant pressure, and here volume V, and here some other volume, but I don't know, we don't know what is the volume. So put it dV. And now see, you have this WDC. See, it is given. WDC is given somewhere. Yes, WDC is given. And you know WDC is equal to WADC, because here work is 0. So WDC is equal to minus PdV, right? Minus PdV. So it is given, this is our equation 2, and WDC is given, that is 95 joules, I think they have given WDC, because WADC is equal to basically WDC. So it is given 95 joules. So you can write here minus PdV is equal to 95 joules. So put here this minus PdV 95 joules. So you will get what? Delta WABC. So this is equal to 3 into 95 joules. So this is equal to how much? 285 joules. 285 joules, and this is the answer. Right? Now see D part, heat change ABC. So D part, W delta Q ABC, this we have to find out. So we know that delta E ABC is equal to delta Q ABC plus delta W ABC. Thermodynamics first law. We have this value, so we can calculate this value. So this is minus 45 joule. This is equal to delta Q ABC plus 285 joules. So delta Q ABC is equal to minus 330 joules, right? And this is the answer. So see, in this way you can calculate different parameters if you have idea about the formula and how to apply the formula, right? How to apply the formula. Now see another question. 2 moles of monoatomic ideal gas is placed on the piston in a cylindrical container as shown here. The piston can move freely up and down without friction and its diameter is 20 centimeter. Okay, a 50 kilogram weight is placed on the top of the piston. The initial temperature of the gas is 0 degrees Celsius, right? Calculate the absolute pressure in the container and calculate the volume of the gas, right? This is initial state of our system. Now the gas is heated to a temperature of 100 degrees Celsius at the constant pressure. And after that you have to calculate this C, D, E and F. So let's start one by one. See, first is calculate the absolute pressure. So all of you are knowing that the absolute pressure of gas in any container is basically equal to the pressure of the gas plus atmospheric pressure. So the absolute pressure is equal to the pressure of gas plus atmospheric pressure. Atmospheric pressure, right? So pressure of gas you can calculate F by A, P is equal to F by A, and atmospheric pressure nothing is mentioned, so you can take it at 10 to the power 5 Newton per meter square, right? Or 10 power 5 Pascal, okay? 1.01325 into 10 power 5 Newton per meter square, as all of you are knowing in the gaseous state we have already discussed. So F is equal to mg, that is given 50 kilogram. G you can take 10 meter per second square divided by area of the piston. This time you can take, so pi r square, so pi into r, radius is what is diameter is given, okay, diameter 20 centimeter, so this is 10 by 100 pi r square, and this is meter square, right? Plus 10 to the power 5 Newton per meter square. So this kilogram meter per second square is equal to Newton. So now you can simplify this like 50 multiplied by 10 multiplied by 100 multiplied by 100 divided by 3.14 multiplied by 10 into 10, okay, plus this is Newton per meter square plus 10 to the power 5 Newton per meter square, right? Now you can solve this. So if you can, you will simplify this. So after simplifying, you can write this 1. This is What the calculation I have done? 1.16, 0.159 into 10 to the power 5 Newton per meter square plus 10 to the power 5 Newton per meter square. So this is basically 1.16 into 10 to the power 5 Pascal. So this is the first answer, right? Hopefully all of you are clear how to calculate the absolute pressure of any system. Now calculate the volume of the gas. So A part is over. Volume of gas. So B is equal to this volume. So behavior is ideal, so you can use V is equal to nRT by P. N is given 2 moles. R you can take 8.314 joules per mole per degree Kelvin. Temperature is 273 Kelvin divided by 1.16 into 10 to the power 5 Newton per meter square. So this is equal to this Kelvin, Kelvin cancel, mole, mole cancel. So after solving this, you will get 0.039 meter cube, right? So this is the answer of the B part. Okay. Now the C part, pressure is constant, P is constant, it is given. So if P is constant and gas is heated to the 100 degrees Celsius, so we can use V by T1 is equal to V2 by T2, right? We can simply use Charles' law. V1 is this. V1 is equal to 0.039 meter cube and T1 is equal to 273 Kelvin and V2 we have to find out and T2 is 373 Kelvin, 100 degrees Celsius. So it is 373 Kelvin. So put all these values here. 0.039 meter cube divided by 273 Kelvin is equal to V2 by 373 Kelvin. So Kelvin to Kelvin cancel. So V2 is equal to 373 by 273 into 0.039 meter cube. So if you simplify this, so you will get 0.053 meter cube, right? So see, all these questions are simple. Now come to the D part. What is this D part? They have asked. Calculate the amount of work done by the gas during its expansion. So basically W is equal to minus 1 to 2 P external dV, right? And you know pressure is constant, so it is given in the question, so you can take it out, minus P external and 0.039 to 0.053 into dV, right? and P external we have already calculated, 1 minus 1.16 into 10 to the power 5 Newton meter square into 0.053 minus 0.039, right? So 0.053 minus 0.039, so this is equal to 0.014. So this is equal to minus 1.16 into 10 power 5 multiplied by 0.014 joules, right? This is what? Volume. So this is meter cube. So this is square and this is cancelled. Newton into meter. This is equal to joules. Now see, this multiplied by 1.16. This is 1.01624. So this is 3 into 5. So you can directly write here 1624 joules, right? So we have calculated W here, work, and this see, work here it is coming negative. Okay, it is true because expansion. So if expansion means work is negative, energy of the system will down. But what is asked in the question, a little bit careful here, because in plus minus students are doing mistake. Carefully study the question. Calculate the amount of work done by the gas. See, it is written in English, the work done by the gas means by work done by the gas, either you have to write in English or you just put negative sign. Negative sign itself manifested that the work is done by the gas. So whenever it is written, okay, work done by the gas, and in your calculation, definitely in your calculation the value will come with the negative sign. But what you have to report here, don't do both the things, means don't put negative sign as well as write in English work done by the gas. So here when we write here, this is the work involved in this process, that is minus. See, this is work involved in this process. Work involved. Now, when you are writing like this, the amount of work done, the amount of work done by the gas, then you have to write this value positive. So you have to write like this, 1624 joules, and this is the answer. But in the expression, whenever it will come into the expression, so you have to use minus 1624, right? Clear to everybody? Because see, this negative, what is the meaning of this negative? That is already here written in English, work done by the gas. If you do not want to write this English, then you just put a negative sign. That's it. So these are the indicators that whether the work is done by the gas or work done is similarly heat absorbed. Suppose that in the question it is asked heat absorbed, and in your calculation definitely it will come positive. So means it is asked, okay, heat absorbed, then simply you can write. If it is asked heat released, so if you have written in English heat released, definitely in your calculation that will come negative. So don't put negative, means heat released and negative sign both cannot be together. So this care should be taken whenever you are solving the problem, right? Now see the next question. Calculate the change in internal energy. C, D, E. Now see, you have two formula to calculate the change in internal energy. That is this delta Q plus delta W. This is one formula, and one master formula I have given you, that delta E is equal to NCV delta T. If you have temperature change in any question, if you have the value of delta T, then don't use this equation to find the change in internal energy. If you have the name of the gas, so that you can find out CV. If you have quantity, although if you do not have quantity, you can take 1 mole. But if you have the name of the gas, have CV, value of CV, and have delta T, then forget this equation, right? So delta T is equal to 100 minus 0 is equal to 100, and all of you are knowing that the difference is equal at both Kelvin scale and degree Celsius scale. So no need to convert here in the Kelvin scale. So delta T is 100. Gas is monoatomic, so this is CV is equal to 3 by 2 R for monoatomic. It is given in the question. And N is equal to 2 moles. It is also given. So now you can simply calculate the delta E by putting this value, right? So delta E is equal to 2 moles multiplied by 3 by 2, R is 8.314 joules per mole per degree Kelvin, and this delta T is 100 Kelvin, right? So this is cancelled, this is also cancelled, so you will get this 2, 2, so it is 2494 joules, right? So this is the answer. Okay, now come to the next part, that is F. Calculate the amount of heat added. See, amount of heat added. So obviously amount of heat added, this should be positive. So in your calculation, this should be positive, right? Let's see. Because when you add the energy to the system, obviously heat to the system, then energy of the system increase, means that value is positive. This time you have delta E, you have work, so you can apply this thermodynamics first law and simply calculate the Q. So delta E is equal to delta Q plus delta W PV, right? So delta Q is equal to delta E minus delta W. So this is equal to delta E, we have calculated 2494 joules minus, and this time when you are putting work here, what this you have to put with the sign, because here in the equation we are not going to use the English, so you have to put this minus 1624 joules. So if you add this, so you will get 4118 joules. So this is the answer. See, amount of heat added and this value positive, right? So basically the terminology work done by the gas, work done on the gas, heat energy released from the system, heat energy absorbed by the system, that and your sign conventions should match to each other. Means when you are writing amount of work done by the gas, definitely in your calculation that value will come negative, but don't write the negative during the writing your answer with this statement that work is done by the gas. Work is done by the gas means you have already indicated, or you have already said that energy of the system is going down. So don't write that moment negative. But if the question is asked how much work involved, so work involved doesn't clearly meaning that done by the gas. So in that case you have to put the answer with sign, right? Good. Well, see another question. Uh, in this question, 1 mole of an ideal gas is taken through a closed cycle A, B, C, A to B, B to C, C to A. Use the information from the graph to answer the following questions. Find the temperature at point A. So at this point, what is the pressure? 400. What is the volume? 4 meter cube, 400 Pascal. 4 meter cube is the volume, and mole, 1 mole is given. So you have moles, you have pressure, you have volume, so you can very easily calculate this temperature. So first part, A, uh, temperature T is equal to PV by N into R, right? So pressure is 400 Newton per meter square. Volume is 4 meter cube. N is 1 mole, and R is 8.314 joules per mole per Kelvin, right? So mole cancel, and all these units were cancelled, and you will get the answer, what, 192.4 Kelvin, right? So this is the answer. Okay, so this is the first part answer. Temperature at point A. Okay, this is the point A. So you have pressure, you have volume, you have number of moles. Second part is the work done by the gas is positive or negative, explain. So in a cyclic system, all we are knowing that if there is a clockwise movement, so if you start from here, coming from here like this, so this is basically a clockwise movement. So when a clockwise movement is there, your path in a cyclic system, perfectly closed system, so the work is negative, right? So the work done is negative, right? Work done is negative. And if you want, you can see here that from A to B there is no work, 0 work. From B to C there is expansion, because here 4 and here 8, so there is expansion. And from C to A there is a compression. So in expansion, V2 minus V1 and negative sign already there in the formula, so you will get what, negative work. So area under this curve is more, and area when you move C to A, so the work is this area under the curve, if you use this method of area under the curve. So basically this is what compression work, and in compression work is positive, and this is what, negative. So area under the curve in the expansion is more, so definitely when you subtract this value, this positive value from this negative, so more negative value is there, so definitely the work is negative. Or you can use this concept that clockwise, so work is negative. Okay, so the net work done by the gas, positive or negative, explain, this is negative. how much work is done by the gas. So you can either use this type of graphical method, means you take area under the curve this minus area under the curve this, or simply area enclosed by this figure. So the work done, C part, work done is equal to area of triangle ABC, right? So this is equal to triangle ABC. Area of this triangle is equal to 1 by 2 into A into C, A into C, AC multiplied by AB. AC multiplied by AB, right? So AC is equal to what? 8 minus 4. So this is 4 meter cube multiplied by this 800 and this is 400. So 400 Pascal, 400 Newton meter square. Right. So this is cancelled. 2 2 are 4. So this is 800 joules. But this is the area math. We have calculated from the math, but we have to put sign here. So the work done or net work done, we can say net work done is equal to minus 800 joule, because this is clockwise. From initial to initial state, we are moving clockwise, so this is negative, right? So C part is over. Is the heat added to the gas or removed from the gas in the entire cycle? See, as we know that it is a cyclic process. We are moving A to B, B to C, C to A. This is a perfect cyclic process. So delta E is equal to, for this cycle, this is equal to 0. So if delta E is equal to 0, then you can write delta Q is equal to delta W minus of delta W, and this minus is by rearranging the variables from left to right. So this negative, so and this will we have calculated minus 800 minus 800. So this is equal to 800 joules, and this value is positive. So the answer is added to the system, right? So heat is added to the system. This is D part. So we have answered A, B, C, and D. How much heat is added? So the answer is 800 joule heat is added. 800 joule heat is added. And next part is what? What is the change in energy for the entire cycle? So the change in energy for the entire cycle, delta E is equal to 0, because this is a state function, right? So in this way you can answer all such type of questions, right? Good. Hopefully all of you are well, I mean equipped to how to use this first law of thermodynamic expressions, right? Now see one more question, and see 1 mole of monoatomic Ideal gas is taken from state A to state B isobarically. Okay, it is clear. The process is isobaric. Uh, how much work is done in this process? So, first part of this question, A part. So, WAB is equal to minus P external uh, A to B, or we can say VA to VB dB, right? So P external here it is given 900 Pascal. So minus 900 Newton per meter square, and VB minus VA. So this is equal to minus 900 Newton meter square multiplied by VB. 6 minus 2, so 4. 4 meter cube, right? So this is equal to minus 3600 joules, right? So minus 3600 joules, this is the work done in this expansion process. This is the first part answer. What is the change in internal energy, whether you have written with U or E? Actually, I am moving E, so EA minus EB, right? So change in internal energy, B part. Change in internal energy. How to calculate the change in internal energy here? Delta E AB. AB. So either you have heat, to calculate this, because you have two formulas for this. Delta E is equal to NCV delta T, right? So this is the one formula, and other formula is thermodynamics first law. But here you don't have the temperature, so but we can evaluate temperature, we can evaluate, no problem, because pressure is known, volume is known, number of moles, 1 mole is known, and monoatomic, more important, monoatomic is known. So we can use this formula NCV delta T. N is equal to 1 mole, it is given. N is equal to 1 mole for this. CV is equal to 3 by 2R, and delta T is equal to TB minus TA, right? So we can write here A to B, A to B, right? So we can write here this is equal to NCV TB minus TA, right? So in place of T we can write NCV TB, we can write PV by NR B minus PV by NR A, right? We can write this. And you know, pressure is constant because the process is isobaric. So this is equal to NCV into P by NR we can take out because N and R are constant. So here we have what? VB minus VA, right? Now put the value. 1 mole multiplied by CV is 3 by 2R into P by 1 mole into R, and VB minus VA, VB minus VA 6 minus 2, 4 meter cube, right? So multiplied by 4 meter cube, right? VB 6 minus VA. So VA is 2. Meter cube, right? So this R and R is cancelled, mole cancel. So this is equal to 3 by 2 into P. What is the pressure at this point? That is 900 Newton meter square into 4 meter cube. 2 to the 4. So this is equal to 5400 joules, right? So change in internal energy is I mean 5400, right? Clear? Change in internal energy. Is the heat added or removed from the gas during this process A to B? So now we can use this thermodynamics first law in this part. So delta E A into B is equal to delta Q A into B plus delta W A into B. So we can write delta Q A B is equal to delta E A B minus delta W A B. So this is 5400 minus W A B. We have calculated minus 3600. Minus 3600. So this is equal to 5400 plus 3600. So this is equal to 0009. So 9000 joule heat to be added, because this is positive. So added to the system, right? So this much amount heat is added to the system, not removed, right? Added, not removed. Now the state of the gas changed from B to C, where the pressure drops 300 Pascal without any change in the volume. See the next part of the question. So we can I can take now I am taking this figure as a separate for this part. Now see. What they have given. The state of the gas change from B to C, where the pressure drops to 300 Pascal. B to C and pressure drops to 300 Pascal without change in volume. So the path is like this, right? So after the gas is compressed to point A isothermally, after reaching here this, we have to compress the gas isothermally to the A. And what we have to do? On the diagram, on the diagram below, show the complete cycle A, B, C, A. Okay, A, B, C, A. We have to draw the path basically. So if we drop, the pressure to 300 Kelvin, 300 Pascal without change in the volume. So this is the point C. And C to A we are moving isothermally. So all of you are knowing that the path of isothermal is like this, right? So this is the isothermal path. So this is B to C because this will be curved. Isothermal path is always curved, not the straight, right? So this. So now the cycle is complete. This is C point, this is B point, and this is A point, and this is what? Isothermal. This is isothermal. Isothermal, right? So this is the complete answer. Okay. So this is the E part, right? So we have discussed so many questions, and hopefully all of you are clear in such type of questions. Okay.